Hi everyone, I'm Surya. I'm working as a DevOps professional for a startup company. I'm here to present my project, which I have done it for Kaggle Capstone. So I'll be sharing the things, and mainly a very big thanks to Kaggle for letting me explore the things there. Thank you. Let's dive into the project now. So here, the first thing I'll show what basically my project is. My project is a multi-agent log incident triad system wherein your entire set of logs, say for example, your Apache Tomcat logs and then HTTPD, basically the Apache server and Lambda server, or else if you have some other extra logs, request response kind of logs, which will be saved into a single place. And then what I'm gonna do is like extract the incident based on the error and then severe and then warn and then plus 2 minutes and minus 2 minutes of the incident particularly occurred. And then I'm extracting that basically using an agent and then reducing it using an agent and analyze it using an agent. This is what I have done. Plus, I have done a security testing over there wherein I'm just trying to send certain commands to my LLM so that the LLM doesn't take it as a serious one and it should consider it basically as a false response or else if somebody is trying to hack in the system. That is what I have done. So let's dive into the main thing here. Here it is. Yes. So the first set wherein I'm installing all the required things here using pip install. My entire programming is based on Python. And then the data set, coming to the data set here entire is a synthetic, a frictional company, slot stay vacation exchange using using the reserved dot example domain and RFC based IP ranges so that it's totally safe to publish my entire project with the data set variable to sample one, a sample two. The sample one, sample two are nothing but the sample cases, the logs basically. So I have in say for example in sample one I have included three incident and in sample two I have included five incident including a connection pool exhaustion and a thread deadlock over there to check the cases. And then the entire notebook follows the pipeline section by section with every number and the chart computed live. And the chart here, which I have shown here, is not like a image, PNG image or a JPEG image. It is totally computed live. It is not a demo thing totally. So if you can see, this is like the entire set of logs here. So these are all the data manipulation which I have done. This is a sample set of logs here. So in stage one, if you see, the stage one here is extraction and time correlation. The extraction and time correlation is based on like which I have told you before, error, warn, exception, timeout triggers, and all those things are correlated within a time window across all sources into one incident report. The timeline chart plots every correlated line with the trigger line marks as X. Say, for example, here. These are all the main things. And then moving to the second stage, that is a reduction. Here, the reduce for llm.py, which I have used, folds long stack traces to their top bottom frames, collapses and repeated lines, trims the entire noise so that we can reduce the entire token. If you see that I have used drain 3 for it to do all the things, and the entire set of logs has been stored into the temp folder, and which will be the incident time over there. If you're seeing here the incident time over here with the extra thing added here underscore reduced dot text. And then moving to see here also, if you can see, all these charts basically are computed live. It is not stored as a JPEG image. And then the stage three here is LLM analysis. So now it is in mock mode by default, so that I'll not burn the tokens which I have got it. I'm considering it as a precious one. You all know that. Then here all the things are mock here. So with the data set which I have told you, sample one and sample two set, I'm setting the entire log over there. And here you can see the incidents, the entire incident has been listed here: incident 1, incident 2, incident 3, and when it has occurred, what has broken, and the customer impact, the impact on the customer set, at the severity level, how to basically fix it, and the status of fixation. That is what I have done. And for the same, I have again introduced a chart level, which is again, it is like computed live, not a this thing. And then this is which I have told you before. This is like my security section wherein I'm trying to do a prompt injections to my model. So I'm just checking all the things. So I have included all the set inside my skills.md file, so that the injection will be stopped over there. And then this is loaded via Google ADK skill. That is from loaded skill from the directory I've used. And then section 8. Sorry, I skipped section 7. The section 7 here is like I've used Google ADK, basically anti-gravity development toolkit for all the things, which in all the three things which you have seen has been added in, injected in as a agent, so that if you want to just reduce the log, you can basically tell the system to just reduce the logs. And then if you want to just extract the things, the individual run, you can do it. And third part is like if you yourself has done it as a reduced part, and you just want to send it to a LLM to check the things, you can do it with the help of all those things. And I'm not hard coding the variable. I'm just taking it from the this thing basically from the CLI, so that the API keys will not be saved over here. And then the final section is outputs. The outputs, I have saved it in outputs directly, wherein you can see the summary JSON, the PNG of all the logs which I have done, and then the incident report and the incident report reduced dot text over there. All those things will be in the temp folder. And then that's it. I'm just coming to the. Thank you very much for providing this opportunity, and thanks, Kaggle.